All right. Oh, my board decided to shut itself off. That's lovely. There we go. So a dot plot of the differences, your dot plot should have looked approximately like this. Why would we need to do a dot plot or a histogram or any kind of picture like this? For normality. Is it required in this case to check for normality? Yes, why? We have less than 30, so we can't use our central limit theorem, and we're not told anything about the population distribution. So we don't have either of those to rely on. So we're going to look at our dot plot of the differences. We only had 10 values to plot, but what are we looking for on the dot plot, or what would we look for on the histogram? Yeah, we want to look for, is it strongly skewed? It might have a slight skew, that's okay. If it is strongly skewed, we would have a problem with normality. And if we had outliers, we would have a problem with normality. Is that going to be an issue here? No. So if we did more and more and more and more and more samples, if we did this over and over and over and over and over, our sampling distribution would look approximately normal. What was the mean? What was x bar of the differences? 3.02. That's what you should have gotten for x bar of the differences. So again, you're taking just actual minus perceived, these values right here, and entering them into a list into your calculator, and then you're calculating one variable statistics on those. And what was the sample standard deviation of the differences? So, what did you say? 1.32. Both of these would come from your calculator. You enter just the differences into the calculator, and that's how you get x bar diff and s diff. And then just one more time for people that weren't here yesterday, the reason that we're only calculating one variable statistics instead of two variable statistics, we have information about the actual time spent online and the parent perception, but both of these pieces of information are about who or what? Same population, the teenagers. This is the teenager's actual time and the parent's perception of the teenager's time. So all the information is being gathered about a single group here. How would we interpret 3.02 in the context of this? Yes, sir. Yep. Or some variation of that. The actual amount of time spent online by teenagers was 3.02 hours larger on average than what their parents perceived or thought. So yeah, your way of writing it was absolutely fine, as long as you make sure that that 3.02 is on average. And then we have to talk about the direction of this. The actual time was greater than the perceived time. So far, so good with these pieces? Okay. So then we get down to calculating our 90% confidence interval. What are the 4 steps that we need to do when we're calculating a confidence interval? State, plan, do, and conclude. What kinds of things do we need in state? Parameter, statistic, and confidence level, yes. All right, so what is the parameter here? Yes, true mean difference in time spent online by teenagers, and you have to give me direction. Actual minus perception, or actual minus perceived. What would we call this parameter? What would be the name of this parameter? Mu diff. And our confidence level is 90%, and then we've got our statistics that we calculated in the previous step. We've got x diff, and then we also have s diff. Let me make sure that that's up here. Of 1.32. What do we need in the plan step? We need the name of the procedure. What's the name of this procedure that we're going to be using? Yes, one sample t interval for mu diff. And then what else do we need in the plan stage? Conditions. What are our conditions? Normality, 10%, and random. Do we have randomness? Yes. Random treatment? Random sample this time. If you look up above, it says a random sample of 10 teenagers were selected. When we did our in-class thing, we used random assignment. We were doing an experiment. This would be a sample. So random sample of 10 teenagers. We have our randomness condition. Do we have our 10% condition? Yes. What is the population that we're looking at here? Teenagers. So 10 is less than or equal to 1/10 of all teenagers. Remember, we need randomness so we can generalize to all teenagers. Why do we need our 10% condition? What'd you say? For independence, yes. So sampling without replacement is okay, so we have our independence. And then do we have normality? Yes, that was the purpose of making that dot plot. The dot plot of the differences has no strong skew or outliers, so the sampling distribution of the mean difference is approximately normal. I want to take just a moment here and talk about language. We have difference of the means. That's when we have two populations. That's like when we did the cookies. We had the two different brands of cookies. That would be the difference of the means. The mean difference is when we have one population but two pieces of information about them that we're subtracting. All right, so state plan, what would come next? Do. What do we need for the do step? General formula. What's our general formula for a confidence interval? Yep. Point estimate plus or minus the margin of error. What is our formula for this situation here? Very close, very close. It's not mu diff, though. It would be x bar diff, because that's my point estimate. I don't know what mu diff is. We're trying to get a range for mu diff here. So x bar diff equals t star, my critical value times s diff over the square root of n. What am I using for t star? 1.833, because we have how many degrees of freedom? 9 degrees of freedom. So I have 3.02, that was our x bar diff, plus or minus 1.833 times 1.32 over the square root of 10. So when I calculated just the margin of error, that was 0.765. You could have done 0.77, that's fine since the x bar diff was rounded to two places. So I got 2.255 to 3.785. If you rounded differently on your margin of error, yours would be a little bit different than mine. So what can we conclude? Yes, and you have to include your direction here as well. Actual minus perceived. Yes, we are 90% confident that the interval from 2.255 to 3.785 hours, make sure you're including units there because that's where we can get some context in, captures the true mean difference, actual minus perceived, in time spent online by teenagers. You don't have to put the direction there in the sentence, but you do have to show me that direction, actual minus perceived. Because when you guys are calculating a mean difference, you might choose to do your subtraction the other way. The interpretation should still be the same. We should still find that the actual is greater than the perceived, but if you did your subtraction the other way, you would have had negatives, and you would have had a negative interval then. So far, so good? Awesome. I want to spend next couple of minutes looking at 3 response questions to help us prepare for the test. So there's one question on the front with 2 parts, one question on the back with 4 parts. I'm going to pass this out, give you guys about 10 minutes to work on this, and that'll leave us about 10 minutes to go over the answers then. Just want to pass it over for me. Thank you, Allison. Go ahead and get started as soon as it is in front of you. Like I said, I'm going to give you guys about 10 minutes, and then we will go over the answers.